first face-off is a bit of a history lesson. HTML versus XHTML. Back in the day, XHTML was this super strict, very proper way of writing markup. You had to close every tab, everything had to be lowercase, it was very particular. But the modern web has pretty much standardized on the flexibility of HTML5. So, for all practical purposes today, you're going to be using HTML's more forgiving syntax.
Now, this is fundamental. Understanding how different elements behave is absolutely key to controlling your layout. Think of it this way. Inline elements, like a span, just want to hang out inside the flow of text. Block elements, like a div, are more assertive. They demand a new line and let you control their size. And then you've got the hero of the story, inline block, which gives you the best of both worlds. It sits in a line, but still lets you set its width and height.
CSS position is your superpower for putting elements exactly where you want them. Relative just kind of nudges an element from where it would normally be. Absolute is more dramatic. It pins an element to its nearest positioned ancestor, which is perfect for things like pop-ups. Fixed literally glues an element to the screen, like a navigation header that never scrolls away. And then there's sticky, which is really clever. It scrolls along with the page until it hits a certain point, and then it locks itself in place.
Okay, this decision right here, it has a huge impact on your site's accessibility. See, pixels, PX, are fixed. They don't scale well for users who might need larger text. Then you have M, which is relative to its parent element, but that can get really messy if you have a lot of nested elements. So the modern champion, the one you should probably be using, is Rem, which stands for root M. It's relative only to the root font size, which guarantees you get scalable and consistent sizing absolutely everywhere.
So where should you actually write your CSS?
Well, you could write it inline, right on the HTML element.
But that's a maintenance nightmare. Please don't do that. For any real project, there's pretty much only one right answer: an external .css file. It keeps your code clean, it's reusable across your whole site, and it allows browsers to cache your styles, which makes everything load faster. Aha, the great layout face-off: Flexbox versus Grid. Honestly, the easiest way to remember the difference is this. Flexbox is for one dimension. Just think of a single line of items, like a nav bar or a row of buttons. Grid is for 2 dimensions. We're talking rows and columns at the same time. It's for the big picture, the entire page layout. The thing is, they aren't enemies, they're partners. You'll often use both on the same page.
Okay, so we've come a long way. We have structure, we have style, our site looks great, but it's static. It's just a pretty picture. To make it actually respond to users, to come alive, we need to add some logic. And that brings us right to section 3, writing clean JavaScript. Think of JavaScript as the electrical wiring for our project. It adds all the functionality, which means writing it cleanly from the start is absolutely crucial if you want to avoid some major headaches down the road. Now here is a classic bug causer: double equals versus triple equals. See, double equals tries to be helpful by converting types. So to double equals, the number 5 and the text 5 look the same. And that leads to some really weird, unpredictable bugs. The solution? Just always use triple equals. It checks for both value and type, which makes your code predictable, safe, and a lot easier to debug. When it comes to declaring variables, it's time to move past the old var keyword. Modern JavaScript gives us let and const, which are block scoped, making them way more predictable. Here's the simple rule. Use let for variables that you know are going to change. For everything else, values that won't change, use const. In fact, a great rule of thumb is to just default to const and only change it if you have to. This one feels a little philosophical, but it's super important. What's the real difference between null and undefined? Well, undefined is what you get when a variable exists, but it hasn't been given a value yet. It's an accidental absence. Null, on the other hand, is a value that you, the developer, assign on purpose to say, this has no value. It's a deliberate, intentional absence.
Okay, our JavaScript is clean and our foundation is solid. So now let's actually make it interactive. This whole section is about handling what the user does, dealing with background tasks, and managing data. You see, by default, JavaScript is synchronous. It runs one line, then the next, then the next. But what happens if one of those lines is a really slow task, like a network request? Well, the entire user interface just freezes. It's a terrible experience. The solution is asynchronous code. It lets those long tasks run in the background, which keeps your UI responsive and your users happy.
Let's say you want to do something when a user clicks a button. The old way was to use an on-click attribute, which mixed your HTML and your JavaScript all together. It gets messy fast. The modern standard is add event listener. It keeps your logic separate from your structure, it keeps your HTML clean, and it even lets you add multiple listeners for a single event. It's just better all around.
When your app needs to talk to a server, you're mostly going to use get or post. The rule is simple. Use get when you're just retrieving data. All the information for the request is right there in the URL. But for sending data, especially if it's sensitive information or a large file, you should always use post. With post, the data is tucked away safely in the request body, which is way more secure. So how do we actually manage all this asynchronous code? Well, the old school way was with promises, which used these dot-then chains that could get really nested and ugly really fast. The modern solution is so much better. It's async wait. It's basically just a prettier syntax built on top of promises, but it lets you write asynchronous operations as if they are happening one after another. The result is code that is so much cleaner and easier to read and debug. And here we are. We've reached the final stage of our developer's journey. Our application is built, it's functional, it looks good. Now it's time for those final touches that make it fast, efficient, and just a joy to use. If you need to save some data in the user's browser, you've got three main options. Cookies are tiny, they can expire, and they get sent back to the server with every single request, which makes them good for things like authentication tokens. For larger chunks of data that only live on the client side, you've got session storage, which clears itself when the tab closes, or local storage, which, as the name implies, is permanent. Now, this right here is a huge innovation in modern web development. You see, directly changing the browser's real DOM is actually a pretty slow operation. So modern frameworks like React use what's called a virtual DOM. It's like a fast, lightweight copy. When something changes, they update that fast copy first, then they use a clever diffing algorithm to figure out the most efficient way to update the real DOM. This minimal change approach is a huge part of why modern apps feel so snappy and responsive.